Thanks. Thank you for all coming and not being scared off by that word sublime. That's not a word you hear a lot at KITP. When I was talking with Lars about coming out here to be the writer-in-residence, he said that one reason they have it is that they want the people here, namely you guys, to know that there's more things in life than physics. And I know you know that, and he knows you know that, but that was one of the, and I'm still trying to figure out what he meant by that.
There's mathematics.
But that's partly why I'm giving this particular kind of talk. Plus, here at KITP, isn't it the case that one reason for coming here is to explore new territories and maybe send your career off in a new direction? And that's sort of happening to me, too. I've done a lot of writing, and what I'm doing now is turning a corner and moving, or hope to move, from nonfiction writing about science to writing about fiction. And let me just go right away to define, well, what the hell do I mean by the word sublime? It dates back to ancient times, but the way we use it now, at least in a literary or an artistic sense, it came about in the early Romantic era, in the late 1700s and late 1800s. Tony Z, sitting in the back, his most famous book, Fearful Symmetry, comes from a poem by William Blake, one of the most sublime of poets. So Tony is an expert on the sublime. And these are a couple of things that my talk is not. I'm not going to talk about religion. I'm not going to talk about my own fiction. You're happy to hear that. Let me start by, So I'm going to talk about, compare sublime as it appears in mostly poetry and fiction with some of the greatest achievements of the physics world. So I'm going to be comparing the best of physics and the best of literature, at least 19th and 20th century literature, using these characters there and one lady as examples. Friedrich Nietzsche wrote a famous essay about the origin of Greek tragedy, and what he said there applied to Greek culture as a whole, and largely to the advent of Western civilization itself. And he said that Greek tragedy grew out of these two huge traditions, which he loosely referred to by the gods Apollo and Dionysus. Dionysus is the god of tragic poetry. Apollo is the god of lyric poetry. So it's not just a mutually exclusive set of characteristics here, but what I'm setting up here, I'm hoping to compare, or at least put some of the words out here that I'm going to use to compare science with sublime literature. For instance, science has to explain things, doesn't it? If it's not explaining something, then you could say it's not really science. Whereas literature entertains. If it's not entertaining, why go on reading the book? Why go on reading the poem if it's not entertaining you? Art is often beautiful. We don't insist that science be beautiful, but some scientific things are beautiful. Truth and beauty are sometimes a paired set of terms that aren't necessarily at odds with each other. Science should certainly be true in that when you measure something or you proclaim the discovery of something, we hope you think you're on the money and what you're saying is accurate. So it should be true. You could say the same thing about a literary character. Is Hamlet a true character? He's true if he keeps to himself, if he's true to his own nature. I'll talk about that shortly. What's the best kind of entertainment? How far can entertainment go? Well, maybe enchantment. You're enchanted by a beautiful poem or a beautiful painting. What is the science? The best that science can do is enlighten us. We've all had those aha moments, eureka moments. One big difference right away is we can say that science does improve insofar as the years and centuries go by, it explains more and more things. Art is a little different. I'll talk about that in a moment. These are some of the oldest astronomical observations dating back to the 7th century BC, conducted in Babylon. They have the star charts. They knew the coming and goings of the planets, but they didn't know a lot more beyond that. This is Ptolemy's model of the solar system, and it's sort of laughable now, isn't it? How can they have ever thought that the planets went around the Earth rather than the sun? Actually, this is the first great mathematical model of antiquity, and it's pretty damn good. Mariners could use it to do calculations to help with navigation. Ptolemy took the Babylonian data with the Euclidean geometry, and what came out of it was Hellenistic astronomy, which is pretty good. Move forward 13 or so centuries, and you come to Kepler, and Kepler is a very, very interesting chap. What I'm calling Kepler 1 illustrates how being beautiful, being seduced by beauty, can work against you. Some of you may have seen this picture. Einstein once said that the equivalence principle was the most beautiful idea he ever had. Kepler's most beautiful idea was that the orbit of Venus, if you drew it as a sphere and you surmounted it with a pyramid, the pyramid would be at about the diameter of Mars's orbit, and then Saturn's orbit and Jupiter's orbit. You circumscribe all the platonic solids all the way out. And he thought he had a theory for why the planets orbited at the distances they did. And we still don't really know that completely to this day, but he thought he was onto something there. And he was wrong. After a few years of holding to this view, he backed off. And then he sort of went in the opposite direction. He was basically a graduate student or a postdoc working for Tycho Brahe, who had much better astronomical observations than these. And Mars, when you watch it from night to night to night, seems to do a loop-to-loop like that. And Ptolemy handled that. Copernicus also had loops within loops, so he wasn't very simple either, Copernicus. Kepler, the truth stared at him again. It was that planets should appear to be going in ellipses, and he did not like that idea. He hated the idea. In one letter, he actually used the word shit. This is what this is, this squashed circle. So great was the imperative to have perfect harmony in the universe. You had to have circles. Copernicus insisted on circles. Galileo, when he heard of Kepler's weird elliptic, he thought Kepler had gone off the deep end. This is Galileo. Galileo was wrong. But this was, it delayed Kepler's repugnance, delayed not for long. And then this chap, 60 years later, explained it all. Maybe the single greatest lurch forward in scientific history, that book. And nowadays, so science keeps progressing. Now we've got these standard models, not just one. This is the one that we look at the most in this room, I guess, standard model, particle physics and cosmology. But here's biology's standard model. There's plate tectonics. You could draw more for botany and other parts of science. Art, not quite the same thing. This is what T.S. Eliot says. Art does not improve. What does he mean by that? I've listed 5 national epics here from across 3,000 years of history. They're all very different. Who's to say that the Iliad is better than War and Peace, or the other way around? These illustrations I've used just to illustrate which is the best paint. Well, that's a modern book cover, but that dates from 2000 BC. This dates from this is a 1700s painting illustrating a 1500s epic. Which is the best? If you're from India or Persia, this is the best looking art. You're used to looking at that. If you're from China, that looks pretty good. I once had a trip planned to go to China. I knew in advance I was going about a year, and I went to every time I went to the Metropolitan Museum in New York, I told myself, I'm going to go to the Chinese wing and learn something about Chinese art. So you stand in the dark, looking at what is said to be some of the best paintings from the Song dynasty, 11th, 12th centuries, and you're in the dark. The Chinese wing is very dark. You look at it and you look at it, and it starts to make sense. And this one time I was watching, came from the Song Dynasty, and I went over to see the probably the most popular room in the whole of the Metropolitan, the Impressionist painting, and they actually rather look very vulgar for about 10 minutes. But I remember being pleased with myself that I was still back there with the Song Dynasty paintings, and these Van Gogh paintings that I loved actually are sort of dismaying for a while. So let's get on to what science does. It makes discoveries. There's Michael Faraday standing at this very podium in the year 1856, giving his talk. Actually, it was at the Royal Institution in London. He gave lectures every Christmas for about 30 or 40 years. Really helped to get the whole idea of science popularization going. It's hard to overemphasize how important his discovery was, induction and the idea of fields. You can't see fields, and yet he knew they were there. They're real. And of course, induction and everything that follows from that, tremendous industrial consequences of scientific discovery. This almost merits the word sublime. Gravity waves is just the most recent of the stupendous steps forward. Do artists make discoveries? Well, one of my favorite literary critics is named Harold Bloom, and he wrote a book called Shakespeare and the Invention of the Human, a pretty pretentious title. What did he mean by that? Here's Brad Pitt and Benedict Cumberbatch. This is Achilles. There's a scene near the beginning of the Iliad where Achilles, who is really angry at Agamemnon, his boss, the general of the Greek army, Agamemnon has stolen away his concubine, and Achilles has his sword half out of the scabbard. And up behind him, invisible to everybody else, is the goddess Athena, who whispers in his ear, "Don't you kill him. He's going to get his in the end. Do you hear me? Are you going to obey me?" And Achilles says, "All right." So the scabbard goes back in. He doesn't kill Agamemnon. That would have messed with destiny if he'd done that. Shakespeare, what does he do? Hamlet is ready to kill Claudius, and something happens. He thinks, "Gee, if I kill him now while he's at his prayers in this climactic, in this important pivotal scene in Hamlet, I'm going to send him to heaven. Is that how I'm revenged?" No, he backs off. So what's going on here? Hamlet is having second thoughts. He's overhearing his own thinking. He has second thoughts, third thoughts. That's what Hamlet is about. This remarkable, maybe the most interesting character in all of at least Western or English literature, Hamlet. Achilles did not have second thoughts. He had thoughts, but Achilles and all down history, there's very little, if any, depiction of second thoughts, of literary characters overhearing themselves. That's what Bloom means. It took Shakespeare, the genius of Shakespeare, to come along, and that was an invention, every bit as much as Mr. Faraday finding induction. Sigmund Freud said that by way of seeking to explain the inexplainable, Hamlet is just too big a thing to explain, but Freud tried. And he said that Hamlet suffered from an Oedipal complex. Well, Harold Bloom comes along and said, no, he's got it exactly reversed. Hamlet didn't suffer an Oedipal complex, wanting to kill his father and marry his mother. It's Freud who suffered from a Hamlet complex. And what he meant by that was that Freud, who saw himself as a scientist for a long time, his most famous discovery was of the human subconscious. And, is that something that you can actually discover? Well, sort of. Freud's, what he thought was his greatest scientific achievement, the invention of psychoanalysis, as a science hasn't stood up very well. Now, I'm not an expert in this field, so I can't give you all the reasoning behind that, but Bloom and a lot of other people nowadays regard Freud not as a scientist, as he viewed himself, but as something more like a literary critic. And there are other, and I won't call this a demotion, what's wrong with being one of the leading essayists of the 20th century, which is what Bloom says Freud is. Edward Gibbon wrote a huge book, The Decline and Fall of the Roman Empire. Nowadays, it's not used as a textbook. It's filled with errors. It's filled with prejudice. But boy, is that prose beautiful. You could read it out loud. I wish I had an hour just to read some of that out loud. He's not a historian anymore. He's passed into literature. I was hoping David Gross would be sitting right there. So my third example, quantum chromodynamics, which he helped to found, the science of how quarks and gluons interact with each other. Who knows how that will be viewed 200 years from now? Maybe David Gross will be seen as Pete Mondrian, as an artist. These quark diagrams. That's what happened. So there's this slippage. And I'm not saying that as anything derogatory. A slippage that what is nowadays science might someday be considered as art. But let's get right down to a specific. As John said, I worked at the Joint Quantum Institute. And so I was involved with this paper because Charles Clark was my boss. This was an article published in Nature. What is a scientific paper like this? It doesn't have to be beautiful. It doesn't have to be eloquent. But it does have a burden of accuracy. It has to be accurate. They did an experiment, and what happened, what they say happened, did happen. You have to be assured of that. There's the burden of attribution. They start piling up references here. 12 references. They're just four lines in, and 12 references already. That's to give people their due, people who have come before. You have the burden of originality. Of course, that's probably true in arts as well. It has to be something completely new. Necessarily, it's highly technical. The quantized orbital angular momentum of photons offers an additional degree of freedom and topological protection from noise, and so on. What they're announcing is orbital angular momentum in neutrons. Here's where I came in. I'm going to talk about this kind of middle category. It's not art and it's not science. It's explaining science. That's what I did. For 30 years, I've been a professional explainer of physics. What are my burdens? What do I have to do as such a in-between person? I have to shape what the Nature article was doing into reportable result. I have to explain all those terms. Orbital angular momentum. Well, I have to back up. What's angular momentum itself? And so on. One thing that I have felt I had to do, and the scientists almost always resist me on this, is to paint a physical picture for the reader or a journalist or the general public, whoever I was trying to reach. A physical picture. I bet a lot of you, when you write your papers, that's not really an important thing, and maybe it doesn't have to be. But boy, orbital angular momentum. Here's spin angular momentum. That's orbital angle. That's the wavefront of a neutron. So what am I going to compare that to? Fiction, the burdens, there are burdens, but they're very different. As I said at the beginning, is it entertaining? Art should be entertaining. If you don't like the book that you're reading, unless it's an assigned text, put it down and read something else. Life is short. It should be beautiful. Is it truthful in the way that I said that truth applies to literature? Does it transport you? A lot of books ought to transport you out of yourself and your problems. And maybe just if we're lucky in the very best of books, the best of novels, the best of poems, it might actually give you an epiphany. That's another word that's a loaded word like sublime that has its origins in religion, but people like Proust, Marcel Proust, and James Joyce helped to drag it over into the literary category. So what we've got now is 3,000 pages of Marcel Proust, Remembrance of Things Past, in a very nice English translation. I'll give you a warning. The next slide is going to be... speakers are always told not to put huge slabs of prose up on the screen, and that's what I'm about to do. So I want to give you this warning. If you don't like seeing that much prose, I'm going to read a whole page. One of the most famous moments in literary history of the 20th century. Just close your eyes. I'm going to read out. You have to hear my voice anyway. So you may just want to... It's about the narrator. He has the same name as Marcel Proust. Marcel, he's a young man. This is from the first of 7 novels that all together make up A Remembrance of Things Past. 3,000 pages. Probably we don't have... are there any French people in the room here? Is it the French masterpiece of the 20th century?
Yeah, probably.
All right, so close your eyes. This is the narrator having a bad day. One day in winter, as I came home, my mother, seeing that I was cold, offered me some tea, a thing I do not ordinarily take. I declined at first, and then, for no particular reason, changed my mind. She sent out for one of those short, plump little cakes called Petit Madeleine, which look as though they had been molded in the fluted scallop of a pilgrim's shell. And soon, mechanically, weary after a dull day with the prospect of a depressing morrow, I raised to my lips a spoonful of the tea in which I had soaked a morsel of the cake. No sooner had the warm liquid and the crumbs with it touched my palate than a shudder ran through my whole body, and I stopped, intent upon the extraordinary changes that were taking place. An exquisite pleasure had invaded my senses, but individual, detached, with no suggestion of its origin. And at once the vicissitudes of life had become indifferent to me, its disasters innocuous, its brevity illusory. This new sensation having had on me the effect which love has of filling me with a precious essence. Or rather, this essence was not in me, it was myself. I had ceased now to feel mediocre, accidental, mortal. Whence could it have come to me, this all-powerful joy? I was conscious that it was connected with the taste of tea and cake, but that it infinitely transcended those savors, could not, indeed, be of the same nature as theirs. Whence did it come? What did it signify? How could I seize upon it and define it? I drink a second mouthful, in which I find nothing more than in the first. A third, which gives me rather less than the second. It is time to stop. The potion is losing its magic. It is plain that the object of my quest, the truth, lies not in the cup, but in myself. The tea has called up in me, but does not itself understand, and can only repeat indefinitely, with a gradual loss of strength, the same testimony. Is this sublime? I would say so. Is it beautiful? I would say so. Some people would say yes, but you want to read 3,000 pages of this. That's why so many people want to read The Remembrance of Things Past. Maybe read, if you can only read one, read the first one, Swan in Love. It's very nice. Is it truthful? You see there, he's worrying about truth. Truth isn't just a scientific thing. Sublime. Let's go back to physics. This is KITP, so I'll talk for 2 minutes about theoretical physics. I just read all that big slab of prose. I'm just going to read a sentence or two here to give you the flavor. Exotic topologically protected zero modes with parafermionic statistics, also called fractionalized Majorana modes, have been proposed to emerge in devices fabricated from a fractional quantum Hall system and superconductor. The fractionalized statistics of these modes takes them an important step beyond the simplest non-abelian anyons, Majorana fermions. Well, all right, it's not Proust. It doesn't have to be Proust. By the way, these guys are all my colleagues at JQI. They're all smart, and because they thought that this paper was really important, I was brought in, like a detective, and it was my job to translate this from Latin into English. And by the way, I've heard a delicious definition once of theoretical. A friend of mine, David Lindley, has written several very nice books about quantum mechanics for the general public, and he said that one of his books had to do with Boltzmann, and he said that David Lindley said that theoretical physics was invented in the mid-19th century to account for atoms, things we couldn't see and weren't going to see for another 60 years. And poor Boltzmann hanged himself. Wasn't working. It probably goes farther back than that, theoretical physics. Isaac Newton the Principia wasn't accomplishment enough. People kept nagging him. All right, yeah, you tell us about gravity, but what is it? And he, nobody can see gravity. Now we can see gravity, sort of. But back then you couldn't, and he was really embarrassed because he couldn't. He said, I'm not going to tell you what it is. I'll tell you how it works. So my burden here, here's the press release I wrote on that occasion. There's my reportable result. The quantum Hall effect to me was always electrons, fermions interacting. Well, they're saying it could be bosons. It doesn't have to be a fermion. But all those terms, oh man, zero mode, anyon, topology, anything with Joint Quantum Institute, just about everything we do is topological. And it's not the topology of soft matter, the sheets or the KPZ stuff you're talking about. It's the heavy-duty quantum topology. Topologically protected because we want to make qubits that stand up to the environment. But I've never had such a difficult press release to craft. It went back and forth in like 10 drafts, and each of the 5 or 6 authors, they all weighed in. I wasn't getting this quite right. I was being a little dumbed down for them, and I respected that. My burden was to be readable. The scientist's burden was to be accurate, and we had to find a way, and this was our compromise. All right, so what am I going to compare to the quantum Hall effect? Emily Dickinson. I feel physically as if I feel physically as if the top of my head were taken off, I know that's poetry. That's one of her most famous. There are, Chris, you're in Amherst, aren't you? So there are 2 UMass people here, aren't there? Anyway, they're right down the road from where this young lady cloistered herself for 40 years and wrote some of the most amazing poems ever. I haven't been to Amherst, so I haven't visited her house, but someday I'm going to make the pilgrimage. And ask yourself: Does science? Has science ever made you feel as if the top of your head was coming off? Did you, in the lab, or anybody here ever feel as if your head was coming off because of some discovery you? All right, that's kind of an embarrassing question to ask. Parafermions are things we can't see. So it really falls into theoretical physics. It may be. It was always my duty when writing these press releases to ask, all right, I know you don't want to talk about potential applications, but are there any? And is there? And they don't want to talk about that because they're just worried about getting this result into Nature of Phys Rev Letters this week. Whereas I know how the rest of society wants to hear about it. They want to hear about applications. But I'm about to put another. It's not a slab of prose, but it is an entire poem by Emily Dickinson. And I'm going to have to, or I feel I need, as the explainer that I am, I'm going to explain a couple of the terms. But she can be as tricky and as abstruse as that parafermion paper. So here goes. The poem is about death, which is about as transcendental a thing as we can imagine. A clock stopped, not the mantles. Geneva's farthest skill can't put the puppet bowing that now just dangled still. An awe came on the trinket. The figures hunched with pain, then quivered out of decimals into degreeless noon. It will not stir for doctors, this pendulum of snow. The shopman importunes it, while cool, concernless no nods from the gilded pointers, nods from the seconds slim, decades of arrogance between the dial life and him. So what the hell does that mean? It's about death. I bet many of you would have guessed that. She's comparing, instead of using parafermion and anion and topology, she has her own coded words. And it's the poet's disdain ever to have to explain. T.S. Eliot once published some notes that went along with his most famous poem, The Wasteland, but few poets do that, and so I'm going to explain just a little bit of it. life, she's saying, is like a pendulum. You know, it's tick-tock, that's your life ticking away, and your face and the attributes of your life are like the dial of the clock. When you die, there's no clockmaker anywhere that's going to bring you back. That no is sort of, I think of that as the grim reaper. You've got death and taxes always in your future. Pendulum of, it's not just a pendulum, but the pendulum of snow. You know, on a sunny day, you see this, our life is constantly like a melting away. I'm going to move on to my last major comparison. A little bit off the screen there. It says 13,000 Feynman diagrams. This is a nice theoretical and an example of where theorists and experimentalists work together very closely. And ever since the 1920s and early 1930s, people have been measuring the magnetic moment of the electron and trying to calculate, with what we now call quantum electrodynamics, what that magnetic moment should be. And here are the best experimental and theoretical estimates at this time. Jerry Gabriel's had a team at Harvard, and he measured the magnetic moment, or specifically, he reports here, the anomalous magnetic moment of the electron to an accuracy of parts per trillion. Parts per trillion. And he worked with the theorists at Cornell who did the theoretical estimate of that, and between them they got what is now a new, better value for the fine structure constant, one of the most important numbers in all of science. Assuming that the electron doesn't have an electric dipole moment, what all these diagrams are doing are really showing you what Jerry Gabriel's not measuring an electron. He's measuring what the vacuum is, and the vacuum is not nothing. It's this frothy, foamy thing, and here's what the vacuum foam looks like. Look at all these electron-positron pair there, photon, virtual photons, electron-positron pair, and they're radiating photons, virtual photons. 13,000 Feynman diagrams they had to put into this calculation. What can I trot forward to compare with this magnificent achievement, theoretical and experimental? How can I come close? You know, what sublime thing can I trot in to compare to that? Well, I've kept in reserve my favorite book, James Joyce's Ulysses. And to compare to 13,000 Feynman diagrams, I'm going to bring a guy named Leopold Bloom on stage. He's a sort of a schlub-like guy. He lives in Dublin in the year 1904. He sells advertisements to newspapers in Dublin. And he's kind of a fuddy-duddy. He's got weird tastes in food, and I'm going to show you. And this is a facsimile from the book. Mr. Leopold Bloom ate with relish the inner organs of beasts and fowls. He liked thick giblet soup, nutty gizzards, a stuffed roast heart, liver slices, fried with crust crumbs, fried hen cod's roes. Most of all, he liked grilled mutton kidneys, which gave to his palate a fine tang of faintly scented urine. This book, it's 800 pages long, so it's not as big as full-blown Proust. It takes place roughly in 20 hours in a day, June 16th, 1904. Because of the protagonist, this day has forever been, or since then, been referred to as Bloomsday. I bet in some of the cities where you come from, there are Bloomsday commemorations. Some in New York City for a long time, I think they're cutting back, but they used to start and read the whole of Ulysses. It takes 36 hours from beginning to end, and they would do it at Symphony Space on the Upper West Side. But there are parades in Dublin. I've been ones in Dublin, Paris, Philadelphia, New York, Washington, D.C. In my town of Tacoma Park, Maryland, we may have one there if I have anything to do with it. He walks around Dublin in this book, and resonances are set up. He's thinking about sex. He's thinking about his wife home in bed. He's thinking about her perfume. He's thinking about the ads he wants to sell. He's thinking about somebody who said something unkind to him the day before. He's worried about his teenage girl in the city of Cork getting herself in trouble. This is a map of Dublin. These are where all the chapters take place. It's estimated that Leopold Bloom walked about 23 miles that day, from early in the morning until late at night. And it's funny, and here's where, the sublime can come into your own life. The most significant, and pardon me for giving you this little personal anecdote, probably the two most significant days in my life are the days that my sons were born. So I naturally think I remember a lot of details from that day. But I can recall, if I had to, a gun was put to my head, recalling days, facts from days. I can probably say more things that happened on June 16th, 1904, than in any one day of my life. Probably more than I could say about day before yesterday. Just because that book resonates with me, and this is sublime art at its best. It takes you out of yourself, takes you to other places. It humanizes you. Ulysses is the most humane book I've ever read. That's a fractal. Even though the things that make it up are only one-dimensional, if it's allowed to continue, it thickens, it thickens, it thickens, it thickens. And a one-dimensional thing, a fractal dimension of 1.5 means that this object is no longer just a line. It's not a one-dimensional thing. It's something not quite two-dimensional either, but it's getting there. I think, just look at that number. In the last century, we fought 2 world wars, and yet the human race was capable of measuring that. And doing this. This guy, he's walking around Dublin, trailing resonances behind him.
So is this some constant for the fractals, or what is this?
What?
What is this number?
I'm sorry. This is the anomalous magnetic moment of the electron.
Oh, no.
This is Jerry Gabriel's number. I'm sorry, from 2006, and I think he cut the uncertainty by another factor of 2 or something in a paper 2 or 3 years ago. So I don't want to give you the impression that James Joyce's Ulysses just works by sheer amassing, parataxis of detail on top of detail. He's one of the few authors that he's delicious at the sentence level. And the last thing I'm going to do here is to show you 3 sentences, 3 lines of prose. He spent 2 weeks just honing these 3 lines of prose. It's in the middle of, it's not a climactic moment. Leopold Bloom is out walking, and he's got a shopping list of things he has to buy. He just bought himself a bar of soap, and he's thinking he just got some money, so he may buy his wife a new pair of garters. And that makes him think of perfume, and he finds himself in front of this lingerie shop in Dublin, 1904. And here are the lines. A warm human plumpness settled down on his brain. Perfume of embraces all him assailed. With hungered flesh obscurely, he mutely craved to adore. That's pretty sublime in my book. And I was in graduate school working on my physics degree when I read Ulysses for the first time, and I just couldn't shake it off. I wanted to make something that beautiful. And so without ever ceasing to be a physicist, I wanted to be a writer, and that's what I've been this very day. That's the end of my talk. Thank you. My feeble attempt to make this room sublime.
If nobody asks a question, I'll ask you. If I make you name a physicist who is closest to Emily Dickinson in spirit, who would you say?
Boy, that's an excellent question. For this talk, I should have studied it, or I meant to, and I didn't. I understand that Paul Dirac was very interested in beauty and disowned certain physical theories because they weren't beautiful enough. Now, he's physicist enough that he can get away saying something like that, but I'll think of that, and when I come up with an answer, I'll...
But Dirac doesn't have this mystical streak that Dickinson had.
She's said, mistakenly, I think, said to be a religious poet. She's not. She may talk about...
I didn't say religious, mystical.
Mystical. Mystical is a word, it's kind of squishy to define, it's sort of like sublime.
I think Tony's wrong about Dirac.
Sorry?
I think you're wrong about Dirac.
I was wrong about Dirac?
Yeah. No, I think that he must have really seen that what he was doing was very beautiful in our sense of the word, and that he was right to say if it looks ugly, it's probably not right.
But that's why I made sure to insert that one Kepler anecdote to the effect that even beautiful math can lead you.
Right.
Yeah.
That's right, and you're supposed to make mistakes.
And he made them, and he manfully said in a second edition of this book, all right, what I said there is wrong. Every time I use the word this, I think, which means force, you're supposed to replace it with another word. He backed off of the mystical.
The talk has been emphasizing the sublime, or the connection between sublime and literature and art and science. But at one point, certainly at the early parts, you did contrast the roles of art and science. You made a point of contrasting it, that science is teaching us something, knowledge, truth, etc., and arts or literature is, you emphasize the entertainment aspect of it, but that has changed over time, hasn't it? I mean, in old days, certainly to the Greeks, wasn't it true that the tragedies were meant to really teach you about the world? Wasn't Shakespeare really teaching us things? It was
I wouldn't disagree. I wouldn't disagree with that. All the Greek tragedies, all of the plays by Aeschylus, Sophocles, they were presented just down the hill from the Parthenon. And they were presented, and you might all have heard that they were competitions, and Aeschylus won X number of awards. It was a competition. There were always 3 or 4 playwrights, but the occasion for that play competition was a religious observance. Those tragedies were meant to glorify or to honor Dionysus. Yes, but I mean, you sort of just encapsulated what the knowledge is that art supplies that maybe science doesn't. Science does not tell you what love is. Science does not tell you what death is. And you might argue, well, neither does Emily Dickinson, but she brought us pretty close. It's this pendulum of snow ticking, and then finally it stops. It focuses the mind. So there is scientific knowledge, and that's wonderful. And there's artistic knowledge, the sublime. Hamlet having second and third thoughts. I mean, we all have second and third thoughts. Shakespeare helps us to think about the second thoughts we have. I suspect I didn't answer your question.
It's an interesting answer.
Any questions? Comments? Let's thank Phillip again.